Welcome to the next course in database engineering. The focus of this course is on advanced MySQL topics. Let's take a moment to review some of the new skills that you'll develop in these modules. In the first module of this course, you'll learn how to create and work with functions, along with both basic and complex stored procedures in MySQL. This is so you can reuse or invoke code blocks to perform specific operations. You'll then learn how to make use of variables and parameters to create more complex stored functions and procedures in MySQL. You'll also learn how to develop user-defined functions for when MySQL's built-in functions don't meet the needs of your project. In the next lesson, you'll make use of MySQL triggers to automate database tasks. You'll explore different types of MySQL triggers like insert, update, and delete. And you'll learn how to make use of each type. You'll also develop an understanding of how you can make use of scheduled events to ensure that your database tasks and events are completed at specific times. The next module focuses on core rules and guidelines for database optimization. In this module, you'll develop an understanding of the concept of database optimization and the advantages it brings to a MySQL database. You'll review techniques for optimizing database select statements so that they're executed quickly and efficiently. For example, targeting required columns or avoiding the use of complex functions. You'll also learn how to work with indexes in MySQL to speed up the performance of data retrieval queries. In the next lesson, you'll be exploring further optimization techniques. You'll start by learning how to use MySQL transaction statements to manage database transactions. You'll discover how you can use common table expressions to manage complex SQL queries by compiling them into single blocks of code. You'll learn how to make use of prepared statements to limit the number of times MySQL must compile and parse code. And you'll discover how to interact with a MySQL database using the JSON data type. In the third module, you'll explore the concept of data analytics in MySQL. First, you'll develop an understanding of the relationship between database analytics and MySQL. You'll discover how to make use of data collected during data analysis by converting it into useful information that can inform future decisions. You'll also explore the different types of data analysis that can be performed within a database. You'll then move on to learn about the relationship between MySQL and data analysis, including the benefits and limitations of MySQL as a data analytics tool. In the second lesson of this module, you'll learn how to perform data analysis in MySQL using SQL queries like joins, subqueries, and views. You'll then explore how to emulate a full outer join in MySQL to extract all records from two tables, including those that don't match. And finally, you'll learn how to extract data from multiple tables using the join method. During these modules, you'll encounter numerous activities designed to test your skills and knowledge. These include lab exercises, knowledge checks, and module quizzes. And in the final module, you'll receive the opportunity to demonstrate some of this learning along with your practical database skill set in the lab project. And you'll also demonstrate your knowledge of these topics in a graded assessment. So, let's get started. In the previous courses, you learned that you could reuse code within your database projects with the use of functions and stored procedures. These methods save you from having to repeatedly type the same code. Over the next few minutes, you'll recap the basics of functions and stored procedures, and you'll also learn about their benefits and key differences. As you might recall, Lucky Shrub frequently make use of these methods to query stock data in the products table of their database. This means that they don't have to repeatedly type the same code each time they check their stock. Over the next few minutes, you'll take a closer look at how they achieve this. So, as you've just learned, the main purpose of creating stored procedures and functions is to wrap or encapsulate code together in the body of a function or procedure. This means that instead of typing the same code repeatedly, you can call a code block to perform a specific operation by invoking the identifier name. But there are other benefits to functions and stored procedures. They make code more consistent and more organized and introduce reusability to make the code easier to use and maintain. Let's look at a few examples of these concepts to find out more. As you just saw a moment ago, Lucky Shrub make use of procedures when checking their stock. First, they create the query as a stored procedure using the create procedure command, followed by the name of the procedure and the required logic. They then invoke this procedure using the call command to extract the required data from the database. If there's no data in the table, then function returns a null value. Let's look at an example of a function. The mod function can be used to find the remainder of the division of two numeric values, x and y. For example, 7 divided by 5. To find the result, invoke the function by using the identifier name within a select statement. In this instance, the result is 2. Remember that unlike stored procedures, a function always returns a value. For example, you might recall the scenario from the last course in which M&G used a function to determine the average dollar amount each client spent with their business. This function always returns a value because it specifically targets clients that spent money. Let's take a few moments to explore a key difference between functions and stored procedures: parameters. Functions can only have input parameters, while stored procedures can have both input and output parameters. Both functions and procedures can accept values within their respective code. In other words, they both accept an input. But only procedures can pass values back out again with the use of output parameters. Don't worry if you find this concept confusing. You'll learn more about parameters in later videos. You can create as many functions and procedures as you need. Just make sure you know when to use one over the other. For example, functions are best when you need to return one specific value, like in a SQL statement or within another function. Stored procedures are mostly for processing, manipulating, and modifying data. So, as you've just learned, functions and procedures are an effective way of reusing code to complete repetitive tasks. And even though they may bring many benefits, it's important to know when to use one over the other. In this course, you'll explore these concepts in more depth. You might already be familiar with basic stored procedures and functions from earlier courses. However, MySQL also offers more complex stored procedures and functions, which rely on variables and parameters. Over the next few minutes, you'll learn how to use variables and parameters to build sophisticated functions and procedures. Lucky Shrub Gardening Center have several repetitive but complex queries they need to create for their database. They can create these queries using variables and parameters. Let's follow their process and find out how it works. First, you need to know what the term variable means in the context of MySQL. A variable represents a placeholder that stores a value. This value may change at times depending on the needs of the query. Basically, variables are used to pass values between SQL statements or between a procedure and a SQL statement. There are two different ways in which variables can be used in MySQL. You can create variables inside or outside of a stored procedure, and inside or outside of a select statement. So what does a variable look like? In MySQL, a user-defined variable is created from alphanumeric characters. You just type the @ symbol followed by the name that you want to call your variable. Then assign a value to your variable using an equal to operator. Make sure that you end your syntax with a semicolon. But how do you create a variable inside or outside of a stored procedure? To do this, you need to use the set command within your syntax. The set command is used to assign a value to a variable within a stored procedure. Let's take a moment to see what the set command looks like in practice. When creating a variable inside or outside of a stored procedure, type the set command followed by the name of the variable. Then assign a value to the variable. For example, Lucky Shrub have an orders table in their database that records orders placed with the business. They can create and use a variable called order ID to target the record with the order ID number of 3. They can now use this variable to delete, update, or query the record. Or you can create a variable inside a stored procedure using the declare command. In this instance, you type the variable name without an @ sign. Then you assign the variable a relevant data type and default value. Lucky Shrub can use this method to create a variable called minimum order cost. The expectation is that this variable stores a value equal to the cost of the minimum order in Lucky Shrub's database. As you learned earlier, you could also create a variable inside a select statement. However, when assigning a value to a variable in a select statement, you need to use the assignment operator syntax. This instructs MySQL to assign a value to the variable. A standard equals operator just checks that one value equals another. So type a select command and then the name of your variable. Then assign a value to your variable using the assignment operator. For example, Lucky Shrub can create a max order variable that retrieves the most expensive order from their orders table. They can then access the value by typing select max order. The output shows the most expensive order. It's also possible to create a variable inside of a select statement and assign it a value returned from a function. You just type the select command followed by the function, then the into keyword and the variable name. Finally, type the from keyword and the name of the table the value must be extracted from. Lucky Shrub can use this method to create a variable called average cost, which returns the average cost of items from their orders table. Now that you're familiar with variables, let's move on and explore the topic of parameters. A parameter is used to pass arguments or values to a function or procedure from the outside. In MySQL, a function only takes input parameters, but there are 3 different types of parameters that can be declared in stored procedures: in, out, and in-out parameters. Let's take a few moments to explore how each of these works. The in parameter is the default parameter. It's used to pass an argument or value to a stored procedure. To use this parameter, type the create procedure command and your procedure name. Type the in keyword in a pair of parentheses. If you don't specify a keyword, then MySQL uses in by default. Then, within your parentheses, add another pair of parentheses with your parameter names. Then add a select statement that outlines the logic of your query. For example, Lucky Shrub can create a procedure that calculates 20% of each employee's salary for tax purposes. They can then call the procedure against a specific salary value. This passes the salary to the procedure and returns the amount due in tax. Next, let's investigate the out parameter. The out parameter is used to pass a value to a variable outside of the procedure. Here's an example where Lucky Shrub use a procedure called getLowestCost to identify the order with the lowest cost in their orders table. They use the out keyword to pass the value outside the parameter. So the next step is to call the procedure. The value of the procedure can then be stored in the form of a variable within a pair of parentheses. To display the variable's stored value, just use a select statement to return the output. Finally, there's the in-out parameter. This is a combination of both parameters. It's used to pass an argument to the procedure and then pass the new value back to the outside. So it's effectively an in and an out parameter. For example, you could create a procedure called square a number that returns the squared value of a specific number using the in-out keyword and a number variable. The procedure expects an input number through the aNumber parameter. It multiplies this number by itself, then returns the result to the same aNumber parameter again. Then you can set a variable called xNumber with a value of 5. Call the procedure using the xNumber variable value. The procedure passes the value through the parameter. It then performs the calculation and returns the result back through the parameter. Use a select statement to output the variable value. You should now be familiar with how to create more complex stored procedures and functions using variables and parameters. Great work. You might already be familiar with MySQL's built-in functions, but what if none of these built-in functions meet your project's needs? No problem. You can develop your own user-defined functions. In this video, you'll find out what user-defined functions are and learn how to create your own. Lucky Shrub are having a sale in which they're offering a 10% discount on selected products. But rewriting the same statement for every product during every transaction would be very time-consuming. Instead, Lucky Shrub need you to create a user-defined function that they can invoke when needed to calculate these discounts. Before you begin helping Lucky Shrub, let's make sure you understand what database engineers mean by the term user-defined functions. You might already be familiar with built-in MySQL functions like string or numeric functions. User-defined functions are created to perform operations that can't be completed with built-in functions. Users develop code that implements equations or formulas to complete a task and return a result. Let's break this process down. A database engineer creates their own code. The code carries out a specific function, and the function then returns the required result. To build a function in MySQL, you can use the create function command alongside the returns clause and the return command. These commands and clauses Specify the data type and values to be returned by the function. Let's find out how this syntax works. Begin your statement with the create function command. Then assign a name to your function. Follow the function name with parentheses and parameters. The parentheses are mandatory, but you don't always need to include parameters. Next, specify the return data type, followed by the keyword deterministic. Deterministic means that the function always returns the same result for the same input parameters. For example, if a sum function is defined as deterministic, then it always returns the same result for the numbers it adds together. Finally, you can implement the logic with a return keyword. Let's look at how Lucky Shrub can make use of a user-defined function. Lucky Shrub can use this syntax to create a function called findTotalCost. A cost parameter with a decimal data type passes a user input value of cost, and the returns clause defines the function's return type as a decimal number with 5 digits. Finally, the return command calculates and returns the final cost after deducting 10%. So each time Lucky Shrub needs to determine the sale price of their items, they just invoke the function in a select statement, followed by the current price in parentheses. But what if you want to develop a more sophisticated function? For example, Lucky Shrub want to offer a 10% discount to customers who make purchases of $100 or more, and a discount of 20% on purchases of $500 or more. The first step is to use the delimiter command to compile the whole function as a single compound statement using begin-end keywords. Then click Enter to change the delimiter from the default semicolon to a double forward slash. Next, use the create function command and name your function getTotalCost. Include a cost parameter with a decimal data type that passes a user input value of cost. The returns clause defines the function's return type as a decimal number with 5 digits, and the return command calculates the final cost after the discount has been deducted. The function is also defined as deterministic so that it always returns the same result for the same input parameters. The next step is to use the begin and end keywords to determine the body of the function. Use an if-else statement to check the input cost and deduct the appropriate amount. Then add the return command to calculate the final cost once the discount has been deducted. Finally, click Enter to create the new function. Then change the delimiter to the default semicolon so you can use MySQL as usual. Now it's time to test the function using a select statement. A customer has just made a purchase that cost $500, so Lucky Shrub need to determine the discount to be applied. Type a select command followed by the name of the function alongside the purchase value in parentheses. Then click Enter to execute the function. The output result is 400, so this customer's purchase now costs $400 following a 20% discount. If you want to drop the function, just use the drop function statement followed by the function's name. Click Enter to drop the function. Lucky Shrub can now apply discounts to their customers' purchases as required. And you now know how to create your own user-defined functions in MySQL for your own specific projects. Great work. You should already be familiar with the process for creating basic stored procedures. So in this video, you'll learn how to create more complex stored procedures that require multiple statements. You can learn how these procedures work by helping Lucky Shrub. Lucky Shrub need to determine the current cost of each of their products ahead of their upcoming sale. They must identify all products that cost less than $50 so they can add an appropriate discount. And they need to identify all products that cost more than $50 for further discounts. The required data is stored in the products table in their database. You can help them to complete this task using a complex stored procedure. First, you need to use a delimiter command so that MySQL can compile the code in a begin-end block as one compound statement. Type the delimiter command to change the delimiter from the default semicolon to a double forward slash. Click Enter to apply the changes. Next, type the create procedure command. Then type the procedure name getProductSummary. Add a pair of parentheses and include 2 out parameters along with relevant variables. These parameters output the low price products and high price products outside of the procedure. They also store the output values in the variables. Next, you need to create the body of the procedure. Implement the logic within the begin and end keywords. The logic consists of two select statements followed by a count command that targets the product ID column within the products table. The first statement returns the ID of all products that cost less than $50. The second statement returns all products that cost more than $50. A double / indicates the end of the query. Click Enter to create the procedure. Finally, change the delimiter to the default semicolon again so that you can keep using MySQL as usual. Now it's time to execute the procedure. Type the call command followed by the name of the procedure. Then, in a pair of parentheses, create the two required variables. You can call the first variable total number of low-price products and the second variable total number of high-price products. These variables hold the output results from the out parameters. Click Enter to execute the call statement. The procedure retrieves data from the table and passes it to each variable. Now you just need to access the data using a select statement. Type the select command followed by the two variable names. Make sure the names are separated by a comma. Click Enter to execute the statements. The output result shows the total number of low and high-priced products. Lucky Shrub now have all the data they require for their sale, thanks to your stored procedure. Good work. As a database engineer, you'll often need certain actions to occur automatically when specific events take place, like when data is inserted, updated, or deleted from a table. But how can you make sure that these actions happen automatically and avoid the need to rewrite code each time they must be invoked? You can do this with the use of MySQL triggers. In this video, you'll learn what a MySQL trigger is and how to code and use them. Lucky Shrub's sales team are adding discounts to products. However, any discounts over 25% must be reviewed by a manager. This means that the sales team needs to add a trigger to the database that flags items when they're assigned a discount above the 25% threshold. Let's explore MySQL triggers and find out how Lucky Shrub can use them to complete this task. The first question to answer is, what's a MySQL trigger? A MySQL trigger is a set of actions available in the form of a stored program. These set of actions are invoked automatically when certain events occur. Examples of these events include inserting, updating, and deleting data from a table in a MySQL database. However, before you can use a trigger, you need to create it. And you'll also often need to drop or delete a trigger once it's served its purpose. Let's take a moment to explore the syntax for creating and dropping triggers. A trigger is created using the create trigger statement. To create the trigger, type the create trigger statement followed by the name of your trigger. Because a trigger is often user-defined, you can create a custom name. However, make sure that each trigger's name is unique within the database. Then define a trigger type. For example, is it an insert, update, or delete trigger? And should it execute before or after? Don't worry about this for now. You'll explore trigger types in a later video. Next, specify which table the trigger must be assigned to and identify how it should be applied to the table. Next, you need to define the trigger's logic. In other words, specify what it is that the trigger must achieve. The trigger can insert, update, or delete data. It can even combine these actions as required. If it requires multiple statements, then these must be enclosed within a begin-end block. Then execute the statement to create the trigger. Again, this part of the syntax isn't a concern at this stage in the lesson. You'll review different types of triggers and what they can achieve in a later video. To drop or delete a trigger that you've created, you can use the drop trigger command. To use this command, just write drop trigger. Then add the if exists clause. This clause makes sure that the drop command only works if MySQL can locate the trigger within the database. If you try to drop a non-existent trigger without this clause, then MySQL returns an error. Next, identify the schema that the trigger belongs to using dot notation to identify both the schema and trigger names. This makes sure that MySQL only deletes the trigger from the specified schema and not the entire database. Finally, type the name of your trigger. Then execute the statement to drop the trigger. It's also important to remember that if you drop or delete a table from your database, then MySQL automatically removes all triggers associated with that table. So, how can Lucky Shrub's sales team make use of these methods? As you learned earlier, the team need to add a trigger to their database that flags when employees attempt to add a discount of more than 25% to an item. An approval request must then be sent to a manager for any flagged items. Lucky Shrub can use create trigger commands to create this trigger. They can name the trigger approval request. They then assign a trigger type of after update so that the trigger executes the logic after an update operation has occurred within the table. Finally, they place the trigger logic within a begin-end block. Finally, let's look at a few more benefits of triggers. Triggers are useful for keeping a log of records or changes made within a database. It's basically a way of maintaining audit trails where a record is inserted into the database each time a change is made. Triggers are also an alternative to constraints. They can be a useful way to help maintain data integrity by making sure all data is updated as required. They're also useful for performing tasks automatically on specified actions on a database table. You should now know what a MySQL trigger is and understand the basics of how to create and drop them within a database. As you might know by now, a MySQL trigger is a set of actions that can be invoked automatically when certain events occur. But how do you determine when and how these triggers are executed? Well, you can control the behavior of your triggers by using different types. Over the next few minutes, you'll explore the different types of triggers available and learn when to use them. Lucky Shrub are rebuilding their orders table, which records orders within their database. They need to assign a new set of constraints or rules on this table. Maybe they can create these rules using triggers. Let's find out which types of triggers Lucky Shrub can make use of and in what order these triggers should occur. First, let's explore the two main types of triggers defined in SQL: row-level triggers and statement-level triggers. A row-level SQL trigger is invoked for every row inserted, updated, or deleted in a table. So if 100 rows are added to a table, then the row-level trigger is invoked 100 times. A statement-level trigger, on the other hand, is invoked once for each action, and it occurs just once no matter how many rows are inserted, updated, or deleted. So a single insert statement could add 100 rows to a table, but it only activates once for all 100 rows. It's important to be aware of both types of triggers. However, MySQL only supports row-level triggers, so they'll be the focus of this lesson. As you learned earlier, triggers are typically used to perform three types of actions: insert data into a table, update data in a table, and delete data from a table. But how can you determine when an insert, update, or delete trigger occurs? Well, depending on when a trigger is actioned, it can be classified as either a before or after trigger. Let's find out what this means. The before keyword or modifier indicates that a trigger must be invoked before any action is performed on a table row, while after indicates that the trigger is invoked after the action is performed on each row. By combining these modifiers with the insert, update, and delete keywords, you can create different types of triggers. For example, the before insert trigger is automatically invoked before an insert event occurs on a table, while after insert is invoked after an insert event. Similarly, a before update trigger is invoked before an update event occurs, and an after update trigger is invoked after the event. Finally, before delete triggers are invoked before data is deleted in a table, and after delete triggers are invoked after data is deleted. In each instance, the syntax is largely the same for each type of trigger. Begin with a create trigger command, followed by the name of your trigger. Next, add the modifier and keyword to determine when your trigger must occur and on what action it must take place. For example, before insert instructs MySQL to invoke the trigger before an insert event occurs on the table. Then type the on keyword and the name of the table. This is followed by the for each row keyword. This instructs MySQL to carry out the action for each row in the table. Finally, type the logic of the trigger. As you might recall, this is usually typed within a begin-end block, particularly if you need to specify multiple statements. Let's look to Lucky Shrub for an example. They want to impose a new constraint on their orders table. This new rule must state that no minus values can be inserted in the table's order quantity field. So Lucky Shrub can begin with the create trigger command. They can then name the trigger order quantity check. Next, they add the modifier and keyword before insert. Then they assign the trigger to the orders tab and make sure it applies to each row. Finally, they create the trigger logic within begin and end statements. The logic states that if the table encounters an order with a value of less than 0, then it must set the value to 0 by default. Now, each time a new row is inserted into the table, the before insert trigger carries out the required action before it inserts a new value. Let's take a moment to explore some more types of triggers that Lucky Shrub can use. Lucky Shrub want to maintain an audit trail of all updates made to their orders table. With an after insert trigger, they can send a log message from the orders table to the audits table each time a new order is inserted. The company also needs to create a log that captures the date and time an order record is deleted from the orders table. They can use an after delete trigger for this task. After a record is deleted, the trigger inserts a record in the log with the date and time. These are just a few examples of how the different types of triggers work in MySQL. You'll explore them all in more detail later in this course, but for now, you should be familiar with the different types of triggers available and know how to create them. Good work. At this stage of the lesson, you should be familiar with MySQL triggers and the different types of triggers available to database engineers. Now let's take a few moments to find out how you can create and drop these triggers into your databases. To help you understand these concepts, let's look at how they're used in Lucky Shrub. Lucky Shrub's database contains an orders table with several columns that record information on each order placed with the business. Lucky Shrub want to make sure that no minus values are inserted in the table's quantity column when a new order is recorded. Any minus values that the table encounters must be set to a default value of 0. They can complete this task using a before insert trigger. The trigger's syntax begins with a create trigger command. This is then followed by the name of the trigger, which is order quantity check. Always make sure that the trigger name is unique within the database. Next, assign the trigger type and specify when it must be invoked. In this instance, it's before insert. In other words, it's invoked before an insert command. Then type the on keyword followed by the table name. This lets MySQL know which table to target. You'll also need to type for each row so that MySQL targets each row within the table. Finally, write the trigger's main logic. This must be a series of one or more SQL statements that execute when the trigger activates. If you have multiple statements, then enclose them within a begin-end block. The trigger's logic checks if a minus value is about to be inserted into the quantity column. This action requires an if statement so that it can access the quantity column. To create this if statement, you need to use one of two modifiers, new and old. New suits our purposes here as it targets the value of a column after the operation. In other words, the value to be inserted. If you needed to access the column value before the operation, you'd use the old modifier. So type a statement that says if the new order quantity value is less than 0, then set the new value to 0. Don't worry if you don't quite understand these modifiers. They're covered in more detail later in this lesson. Now let's find out how to run our trigger. Before running this trigger, make sure you redefine the MySQL delimiter semicolon to a // Then execute the trigger. Once executed, change the delimiter back to a semicolon. Lucky Shrub now have the required trigger in their orders table. Lucky Shrub now need to delete this trigger from the table. You can delete or drop the trigger using the drop trigger statement. Type drop trigger. Then type the if exists condition to prevent MySQL from returning an error. Next, provide both the schema name and the trigger name using dot notation. The schema name is optional, but still recommended. It helps MySQL target the correct trigger. And don't forget that if you drop the orders table, then all related triggers are also deleted. You've now helped Lucky Shrub to create and drop the required trigger from their database. And you should now be familiar with how to create and drop triggers from your own databases. Great work! When working with MySQL databases, there'll often be tasks or events that must be completed at specific times, like inserting data or generating reports. With MySQL scheduled events, you can make sure that these events occur at the scheduled time, even if you're not present. In this video, you'll learn what a MySQL event is, review the syntax used to create events, and explore some examples. Lucky Shrub often make use of MySQL scheduled events. For example, the finance department has just requested a report on all orders received this month. However, this report must be generated at 11:59 p.m. on the last day of the month. Lucky Shrub can use a one-time event to create this report. They can schedule their MySQL database to generate the report at the specified time and date. Before you find out how Lucky Shrub can create this event, let's first find out more about what a MySQL scheduled event is. A scheduled event in MySQL is a task executed according to a given schedule. In other words, it's an event that takes place at a specified time. Each event has a unique name and contains one or more SQL statements. They're stored in the database and can be executed just once, or they can be a recurring event. The main types of scheduled events that you'll work with in MySQL include one-time events and recurring events. One-time events are scheduled events that occur just once, for example, inserting data into a table 1 hour from now. And a recurring event is a scheduled event that occurs on a regular basis, like generating a weekly report from a database. So, how do you create a MySQL scheduled event? Events are created in MySQL using the create event keywords. Let's find out more about how this syntax works. First, create the event using the create event keywords. You can follow these keywords with if not exists. This tells MySQL to create the event only if it doesn't already exist. Then follow these keywords with a unique event name. Next, type the onSchedule keywords and specify a scheduled time at which the event must occur. Then type the do keyword. This keyword is followed by the event body in which you specify the logic of the event using SQL statements. So, how can you use this syntax to differentiate between one-time and recurring events? If your scheduled event is a one-time event, then specify the schedule using the @ clause. This is followed by a timestamp, an interval keyword, and a specific time at which the event must be executed. For example, Lucky Shrub can use this syntax to generate a one-off revenue report 12 hours from now. And they can create their event logic within a begin-end clause. Creating a recurring event is more complicated. The syntax is largely the same. The key difference is that you must use the every clause instead of @, followed by an interval. You can also use the starts and ends keywords with the timestamps and intervals to designate specific start and end points for the event. Lucky Shrub can use the recurring event syntax to create a daily stock check event. If the event identifies that some stock levels are too low, it sends out an order to restock those items. You'll find out more about how Lucky Shrub can create this and the previous event in just a moment. Before then, let's look at how to delete or remove an existing MySQL event that's no longer needed using a drop event statement. First, type the drop event keywords. It's also good practice to include if exists. This tells MySQL to check if the event still exists and hasn't already been dropped from the database. Finally, type the event's name and then execute the statement. Now that you're familiar with scheduled events and their syntax, let's see if you can help Lucky Shrub generate that report. As you saw earlier, Lucky Shrub's finance department has just requested a report on all orders received this month. They need the report generated at 11:59 p.m. on the last day of the month. However, it's now the last day of the month and it's also approaching 12 noon. So they need the report 12 hours from now. This is a one-off event. So begin with the create event keywords. Then assign the event a unique name. Let's use generate revenue report. Now you need to specify the schedule. Since this is a one-time event, use the @ clause. Then schedule the event to occur 12 hours from now. So include the current timestamp and add a 12-hour interval. The next step is to add the schedule's logic. Type the do keyword and a begin and end block. Within this block, instruct MySQL to select all data inserted into the orders table this month and to place that data within a report data table. Great! 12 hours from now, the finance department will have their report. Lucky Shrub need your help with another task. They're reviewing their stock and need to make sure that they have at least 50 units available for each item on sale. You can help them by using a recurring event. First, create the event and call it Daily Restock. Then specify the schedule. As this is a recurring event, use the every clause and schedule it to occur once a day. Next, add the do keyword followed by a begin and end block. Within this block, define the event's logic. MySQL must check if the number of items for any record in the products table is below 50. If MySQL locates a record below 50, then the number of items must be updated. If at any stage you need to remove this event, just type the drop event keywords, then if exists, followed by the event name. Great work! You've helped Lucky Shrub to create these events in their database. You should now be familiar with the basics of MySQL scheduled events, include different types of events and their syntax. Well done! Congratulations! You've reached the end of the first module in this course. Let's take a moment to recap on some of the key skills you've gained in this module's lessons. In the first lesson, you received an introduction to the course in which you learned about the role of an advanced database engineer in Meta, discussed what you hope to learn with your classmates, received an overview of the topics that you'll cover in this course, and you enhanced your knowledge by reviewing some key additional resources. In Lesson 2, you learned about Advanced MySQL functions and stored procedures. You learned that the main purpose of creating stored procedures and functions is to wrap or encapsulate code together in the body of a function or procedure. The benefits of stored procedures and functions is that they make code more consistent, more organized, and introduce reusability to make the code easier to use and maintain. And you also know that the key difference between functions and stored procedures is parameters. Functions can only have input parameters, while stored procedures can have both input and output parameters. You then learned how to make use of variables and parameters to create more complex stored functions and procedures in MySQL. You learned that variables are used to pass values between SQL statements or between a procedure and a SQL statement. You can create variables inside or outside of a stored procedure, and inside or outside of a select statement. You learned that a parameter is used to pass arguments or values to a function or procedure from the outside, and that there are 3 different types of parameters that can be declared in stored procedures: in, out, and in-out parameters. You also learned how to develop user-defined functions for when MySQL's built-in functions don't meet the needs of your project. A database engineer creates their own code. The code carries out a specific function, and the function then returns the required result. In Lesson 3, you explored MySQL triggers and events. You discovered that a MySQL trigger is a set of actions available in the form of a stored program. These set of actions are invoked automatically when certain events occur. Examples of these events include inserting, updating, and deleting data from a table in a MySQL database. The 2 main types of triggers used to manage SQL events include row-level triggers and statement-level triggers. Next, you discovered how to create and drop these triggers in MySQL. You can now create a trigger using the create trigger statement and drop or delete a trigger using the drop trigger command. You also reviewed other aspects of the syntax used to create a MySQL trigger. This includes defining the trigger name and type and specifying the logic by enclosing multiple statements within a begin-end block. You then learned about MySQL scheduled events. As part of this lesson, you reviewed the syntax and process steps for creating a scheduled event in MySQL. You should now be able to work with functions and triggers in a MySQL database. Well done! I look forward to guiding you through the next module in which you'll learn how to optimize a database. You need your databases to respond quickly to your SQL queries, but as your data volumes grow and your data requirements become more complex, the response times can increase. Fortunately, you can use database optimization to improve the performance of your databases. In this video, you'll learn about the concept of database optimization and its importance. Over at Lucky Shrub, they've had a large increase in clients and orders during their latest sale. Their data volumes have grown considerably, so they now need to make sure that they can still retrieve information from the database quickly. Let's find out more about database optimization and discover how Lucky Shrub can optimize their own databases. Database optimization is improving the performance of a database system to reduce the time it takes to query, process, and transmit a user's query. Basically, it's the process of maximizing the speed and efficiency of the database's performance. An optimized database can process a SQL query and return the required data fast. It's also important to note that database performance depends on hardware and software. In this lesson, you'll focus on optimizing queries using MySQL software. At this stage of the course, you've encountered a lot of different kinds of SQL statements. These SQL statements can be divided into 2 categories. Data retrieval statements, which return data from the database, these are also known as select statements, and data change statements, used to alter data within the database, like insert, update, and delete. Both types of statements require different kinds of optimization. Later in this module, you'll explore optimization techniques in detail, but for now, let's look at the basics. Data retrieval statements are select statements. There's a lot of work involved in optimizing select statements, and it typically involves indexes. An index is a type of handle that you can use to quickly look up data. Indexes are created on table columns. You'll learn more about indexes later in this lesson. Other methods for optimizing select statements that you'll encounter in this lesson include targeting specific columns in the select command, efficient use of functions and wildcards in predicates, and making use of inner joins instead of outer joins. You'll also learn about deploying the distinct and union clauses and explore the importance of using the order by clause to sort results. Different methods are required for optimizing data change statements. For example, to optimize update and delete statements, you first need to optimize the conditions in the where clause. And insert statements can be optimized by performing batch inserts. This means inserting more than one row in a single insert operation. For now, you just need to be aware of the distinction between data retrieval and data change statements. You'll explore them in more depth later in this lesson. Although database optimization can be complex, it's worth the effort. As you've learned, an optimized database offers improved performance with faster turnaround times, and it removes unwanted task loads from the database. By optimizing their database, Lucky Shrub can process their sales data much more quickly and efficiently. They'll avoid any potential issues that could arise from the growth in data. You should now be familiar with the concept of database optimization, along with the different kinds of SQL statements that can be optimized. Good work. When working with a database, it's important that your SQL queries are compiled and executed quickly and efficiently by the database. But this can only happen if your queries are optimized. Over the next few minutes, you'll explore techniques for optimizing select statements. Lucky Shrub have received large numbers of orders from their clients. This has led to increased volumes of data in their database. They need to query this data using select statements. To improve the performance of their queries, they'll need to make sure that the statements are optimized. Let's find out more about optimization guidelines and explore some techniques that Lucky Shrub can make use of. As you might already know, select statements belong to a category of SQL statements called data retrieval statements. These types of statements are designed to return data from the database, but if they're not optimized correctly, then they add extra load to the database and slow down its performance. This means that it then takes longer for the database to execute your SQL select statements or queries and return the data you need. However, there are a few basic guidelines or best practices that you can follow to optimize your select statements. You might already be familiar with some of these methods. Target only required columns in your select clause. Avoid using functions in predicates and avoid using a leading wildcard in predicates. Use inner join where possible. And make use of distinct and union clauses only when necessary. Let's take a few moments to explore some examples of these guidelines. When querying a table, you might often make use of an asterisk in your select statement to extract all available data. However, instructing MySQL to query all data in a table adds extra load on the database and slows down its performance, particularly if you only require data from specific columns. A more optimal approach is to list only the columns in your statement that hold the data you require, instead of using an asterisk. Lucky Shrub can use this method to target the required data in their orders table and return the data faster. Another common mistake that database engineers make is using MySQL functions in predicates that refer to columns which aren't indexed. A predicate is an expression that returns a true or false value. An example of this is where clause conditions. You should also avoid using functions in the where clause on a column that's indexed, because this prevents the database from using the index. You'll explore indexes in more detail later in this lesson. Using a leading wildcard on predicates can also lead to a slowdown in the database. An example of this is using patterns that begin with a wildcard when combining the like operator in the where clause. MySQL can't make use of an index in a column during a search when it's matched against a pattern with a leading wildcard. Another method for optimizing databases involves using the inner join instead of the outer join where possible. An outer join retrieves all records from both tables, including rows that don't contain matching values. This takes longer for MySQL to process. The inner join is more efficient because it retrieves only the necessary data or matching records from both tables. This helps to optimize your queries. Often, when creating SQL queries, you'll use the distinct clause to eliminate duplicate values or the union clause to combine multiple query results. This can slow down the query because it must perform a sorting operation and eliminate duplicate records. However, if you use union all instead, then this eliminates the need for a sorting operation and speeds up the execution process. You should now know how to optimize MySQL Select queries and be familiar with basic optimization guidelines. Well done. Lucky Shrub have received large numbers of orders from their clients and need to query this data quickly and efficiently using select statements. They must make sure their queries are optimized so that MySQL can compile and execute them efficiently. First, the sales department needs to find out which orders are arriving on September 12th. They can write a select query that uses the where clause and date_add function. But sorting through the data to calculate delivery dates using the date_add function in the where clause places a lot of extra load on the database. A more efficient method is to generate a custom column in the orders table called expected delivery date. This column shows the expected date of each delivery. So now Lucky Shrub just need to scan this column for all values that match September 12th, and they no longer need to use a function. The sales department's next task is to process an order for a customer with the surname of Ito. First, they need to find the customer's details in the clients table in the database. One method is to use a select statement that combines a leading wildcard with the like operator. But MySQL can't make use of an index when there's a leading wildcard. The solution is to add a new column to the client's table using an alter table statement and call it reverse full name. The reverse full name column contains the client names but reversed. In other words, the client's last name or surname is listed first, then their first name. You can run an update statement on the client's table to carry out this task. Next, use the create index syntax to create an index on the new column. Don't worry about this syntax for now, you'll explore it in more detail in a later video. You can now make use of a trailing wildcard with the like operator on the reverse full name column to achieve the same result. And you can still use the index. Finally, the finance department need a report on all orders placed with the store. They can extract this information by targeting the product and orders tables in the database. Usually, this task could be completed by using an outer join query. However, this type of query also returns records that don't match from both tables, even though they're not required. A more efficient method of querying these tables is for Lucky Shrub to use an inner join that targets the shared product ID columns from both tables. This returns only the matching records, so it's a much more efficient way to execute the query. You should now know how to optimize MySQL Select queries and be familiar with basic optimization guidelines. Well done. When performing data retrieval, MySQL often scans an entire table, even though it only needs to locate specific column values. These queries take a lot of time to execute and place extra load on the database. But MySQL can execute these data retrieval queries faster with the use of indexes that target specific column values. In this video, you'll learn how to use indexes to speed up data retrieval. Over at Lucky Shrub, the sales department needs to retrieve the contact numbers of clients from the database. But there are thousands of clients and phone numbers to sort through. Fortunately, Lucky Shrub can make use of indexes to retrieve this data faster. Before you explore Lucky Shrub's process, let's take a few moments to get a better understanding of indexes. An index is a data structure that helps to maintain pointers that lead to sorted data. Although you can't see an index within a database, it's still helpful to visualize it as a table that contains two columns, one for pointers and another for sorted data. For example, Lucky Shrub can use an index that lists pointers in one column and the full names of clients as sorted data in a second column. There are two types of indexes used in a MySQL database. The first is a primary index, also called a clustered index. The second is a secondary or non-clustered index. A primary index is an index that is stored within the table itself. It's generated automatically once you create a table that contains a primary or unique key. The index enforces the order of rows in the table within the table itself. A secondary index is created using the MySQL create index statement. The syntax begins with create index, then write the name of the index. A commonly used approach is to write the name of the column you want to create the index on, prefaced by IDX for index. Next, use the on keyword to assign the index to a table. And finally, add a pair of parentheses and write a list of columns that the index is to be used against. An index can be created using one or more columns from a table, but you should only create indexes on columns that you'll frequently perform searches against. This is because when you update or insert data into the table, that same data must also be added to or updated within the index, which takes time. Lucky Shrub can use a secondary index to optimize their SQL Select query. They can create an index on the full name column so that client details can be located faster. Now that you're more familiar with the concept of an index, let's see if you can use your new knowledge to help Lucky Shrub. Lucky Shrub need to find the contact number for the client Jane Delgado. However, there are many client names to search against, and MySQL must scan all rows until it locates the correct name. Let's quickly review the approach that MySQL usually takes to complete this task. First, type the explain clause to output data that explains how the database executed the query. You can pinpoint potential bottlenecks and suboptimal queries by reviewing the output. Then type a select statement that selects a contact number from the client's table that matches the value of Jane Delgado. Press Enter to execute the query. The query returns the contact number for Jane Delgado. But as the output results have shown, MySQL had to scan and filter 10 records before it found a matching value. The possible keys column also shows a null value. This means that there's no key or pointer that can help to make the search easier. So the solution is for Lucky Shrub to speed up the search process by creating a secondary index. First, type create index. Then add IDX for index to the full name column. Next, target the client's table using the on keyword, and then place the full name column name in parentheses. Finally, execute the statement to create the index. To test the efficiency of the index, you can create and execute another explain statement. This time, the output result shows that MySQL only had to locate one row, and it was able to locate possible keys using the index full name index. This means that Lucky Shrub's SQL Select query can now search the index and locate the data faster instead of searching through all records in the client's table. And you should now be able to explain what an index is, outline the differences between primary and secondary indexes, and describe the process for creating an index. Well done. How often have you encountered an error during a critical activity, forcing you to begin the task from the beginning? This can be particularly stressful when you're working on many related queries at the same time. Thankfully, you can use MySQL transaction to roll your database back to a previous state. In this video, you'll learn how to manage database transactions with MySQL transaction statements. Lucky Shrub are updating new sales in their orders table and the stock levels in their products table. To carry out this transaction, Lucky Shrub need to create and execute several different queries. But they could encounter an error at any point in the process. For example, the internet connection could fail while inserting data into the table, and this could result in invalid data or an incomplete transaction. However, if such an event were to occur, Lucky Shrub can roll back their database and restore it to its original state using transaction commands. So, what are transactions in MySQL? As you just saw with Lucky Shrub, a transaction in MySQL is one or more queries that can be committed permanently to the database, and the database can be rolled back to its original state if any of the queries fail to execute as required. MySQL provides the following set of statements for managing database transactions: start transaction, begin or begin work, commit, and rollback. Let's explore each of these statements in more detail. Start transaction is the standard SQL statement for starting a transaction process. This syntax marks the point that you'll return to should you decide to roll back the process. So begin your syntax with start transaction. Then list your SQL statements underneath. For example, Lucky Shrub can begin their database updates with a start transaction statement, and then follow this with a list of the required SQL queries. However, start transaction isn't the only way to begin a transaction. With MySQL, you can also use the begin or begin work aliases as alternative ways to initiate a transaction, Whichever method you choose, once you've finished typing your SQL statements and you're happy with the result, then it's time to commit the transaction to the database. You can use the commit statement to commit the transaction changes permanently to the database. Just type the commit statement at the end of your code block. But what if you encounter an error during your transaction, like Lucky Shrub and their internet connectivity issues? Or maybe you typed incorrect code, executed the wrong statement, or entered incorrect data. You can use the rollback command to roll back the current transaction and cancel the changes made to the database. Just add the rollback statement to the end of your SQL statements to return to your start transaction point. However, it's important to remember that the rollback statement must be enacted before you commit your SQL statements. Once you've rolled back your code, you then need to type the correct SQL statements. And once you're happy with these statements, type commit to commit the changes to the database. So let's quickly recap the process. Begin your transaction with start transaction. Type your required SQL statements and use commit to commit your changes to the database. And should you encounter any errors or other issues, just use the rollback statement to return to your start transaction point. Now that you're familiar with MySQL transactions and the related statements, let's see if you can help Lucky Shrub update the sales and stock levels in their database tables. A client with an ID of CL1 has just placed an online order for 10 bags of artificial grass. This item has a product ID of P1 in the products table. There are currently 100 bags in stock. This number must be updated to 90 once the client's order is processed. First, type Start Transaction to determine the point you can roll back to if an error occurs. Now you need to add the required SQL statements. The first is an Insert Into statement. This statement inserts a new set of values into the required columns in the orders table for the client's order. Then type an update statement that updates the number of bags of artificial grass in the products table by deducting 10 units from the current stock level. The next step is to use a select statement that creates an inner join between the orders and products table using the product ID key, which is common to both tables. Execute this statement to check if the transaction was completed as you expected. Unfortunately, it looks like there was a mistake. These updates have been applied to the client with the ID of CL11. It seems you typed the wrong client ID in your code. No problem. You can restore the data by using the rollback statement. Now check the orders and products tables again using select statements. All data has been restored to its original state. So let's type Start Transaction once again, followed by the same SQL statements as before. Only this time, make sure to update the correct client details. Once you've completed your new set of SQL statements, check that the output is as you expected. Great, this time all details are correct. You can now type commit to commit your changes to the database. You should now be able to manage transactions in your MySQL databases using transaction statements. Great work. When working with databases, you'll often need to write complex SQL queries. These can be difficult to manage. However, you can optimize these queries by compiling them into simple blocks using a common table expression, or CTE. In this video, you'll learn how to make use of CTEs to optimize your database queries. Over at Lucky Shrub, the finance department must calculate the average sale for each customer over the last 3 financial years. To carry out this task, Lucky Shrub need to create one select statement that contains several complicated SQL queries that include functions, strings, operators, and clauses. Fortunately, you can help Lucky Shrub to minimize the complexity of these queries using a CTE. Before you help them out, let's explore the basics of a CTE. A CTE is a method of optimizing complex database queries by compiling them into simple blocks of code. These blocks can then be used to rewrite the query by calling the CTE when required. This simplifies the query and makes it much easier to read and maintain. A common table expression can be created for one or multiple queries. It all depends on the requirements of your database. Let's begin with an exploration of the syntax for a single CTE. The syntax for a single CTE query uses the with clause to start the common table expression. This is then followed by the name of the CTE. This can be a custom name. The as keyword is then used to associate the query within parentheses with the CTE name. Finally, create a select statement to query the name of the common table expression. The syntax for creating multiple queries is a bit more complex. Start your code block using the with clause. Then list the queries underneath the with clause. Make sure that each query has a unique name and is separated by a comma. Finally, type your select statement. To execute a CTE, type its name after the select statement. Or you can execute multiple CTE at once. To execute more than one CTE, add a select statement for each CTE. Place a union operator in between your statements to return data for all statements in the output result. For example, Lucky Shrub can use multiple queries to calculate their average sale. Let's explore Lucky Shrub's use of CTEs in more detail. See if you can help them out using your new skills. As you discovered earlier, Lucky Shrub need to calculate the average sale over the last 3 financial years. Their current approach is to create 3 separate select statements, one for each year. The statements are combined using a union operator. Each statement calculates the average cost by using aggregate and string concatenation functions. The data is extracted from the orders table and the conditions are specified using a where clause. You can click Enter to execute these statements and return the average sale for each year. Although they work as intended, these queries are quite complex and difficult to manage. But you can use a common table expression, or CTE, to improve their readability. Start by using the with clause. Then rewrite the first expression as average sales 2020, followed by the required logic. You can use an as keyword to return it as average sale for improved readability. Then create the second and third expressions. Use the as keyword to associate the expression with the query and make sure that each expression is separated by a comma. Now you just need to type 3 select statements. Each statement uses an asterisk symbol to extract all data from each of the 3 expressions. Place union operators between the queries to combine the results. Finally, press Enter to execute the code. The output is the same as the last query you executed. However, this time you've created a query that is more optimal. All expressions are now contained within a simple block of code that is easy to read and maintain. You should now be familiar with how to use a CTE to optimize your database. Nice work. Each time you create a statement, it must be compiled and parsed by MySQL before it can be executed. This process uses a lot of resources. A more efficient method is to create a prepared statement that can be used repeatedly without requiring clearance each time. In other words, you can create a prepared statement that MySQL compiles and parses just once before it's executed. The statement functions as a template that holds unspecified values as parameters. These values can then be added as required. Each time the statement is invoked, MySQL knows it's safe to execute. This is a much more efficient and optimal way of executing statements without using valuable MySQL resources. Let's look at an example of how to create and execute a prepared statement from the Lucky Shrub database. Lucky Shrub need to extract data on customer orders from their orders table. Let's help them carry out this task using an optimized prepared statement. The prepared statement must return the following information from the orders table in the database for each specified record: client ID, product ID, quantity, and cost. The first step is to prepare the statement using the prepare command. Then type the statement name. This can be a custom name. In this instance, you can call the statement getOrdersStatement. Then type the from keyword. Follow this syntax with a select statement in single quotation marks. This select statement extracts the required data from the orders table against a specified value. However, you might have noticed that the value is currently unspecified because it requires an input value. Later, you can enter any value you like to process the statement with a new argument. You don't have to wait for MySQL to compile and parse the statement. Click Enter to execute the statement. The database returns the output result, a confirmation message that declares statement prepared. The getOrderStatement is now ready to use. Next, you need to declare a variable named order ID and assign it a specific order ID. Let's use an ID of 10. Now you can use this variable with the prepared statement. First, type the execute command followed by the statement name. This command is used to execute prepared statements. Next, type the using keyword followed by the variable name. The using keyword specifies the variable value to be passed to the parameter in the prepared statement. So this prepared statement is basically instructing MySQL to extract the client ID, product ID, quantity and cost data associated with the order ID 10 in the orders table. Click Enter to execute the query and return the results. Although this prepared statement targeted the order ID 10, you could also target any other order ID from the orders table. The statement can extract the related data and it doesn't have to wait until it is compiled by MySQL. You should now be able to create and execute a prepared statement in MySQL. Well done. As a database engineer, you need to work with many different types of data. This can place a lot of pressure on MySQL's resources as it compiles and parses through these different data types. One method of optimizing MySQL's use of resources is to store data using the JSON or JavaScript object notation data type. JSON is an easy method of communicating data between different database systems, and it stores data in a simple text format that doesn't require any special parsing. Here's an example of a line of JSON code from the Lucky Shrub database. Lucky Shrub used this line of code to store properties and assign them specific values. This line of code is placed within a pair of single quotation marks and curly braces within the insert into statement. Each property and value are typed in double quotation marks and separated by a colon. These are known as key value pairs. Each pairing is separated by a comma. Let's explore how Lucky Shrub makes use of this MySQL JSON code in their database. Lucky Shrub need to track the actions of clients who use the online store as they browse Lucky Shrub products and place orders. Lucky Shrub can capture this information and store it in JSON format in MySQL. MySQL can then quickly and efficiently process this data. First, create a table called activity that stores client activity. Then create two columns. The first column is called Activity ID and provides a unique identifier for each client activity using an integer data type. The second column is called Properties. This is a JSON data type column. It stores the properties of each client activity, like client ID and product ID. It also records if the client has placed an order by placing either a true or false value next to the order property. The next step is to populate the table with data. Create 3 activity IDs and then log client activities using JSON code for 3 client IDs. 2 of these clients have ordered products. 1 client has not ordered a product. Now you need to retrieve data from the properties column. Since you're working with the JSON data type, you need to retrieve or access this data using a column path operator. Type a select statement that selects the activity ID and properties columns. For the properties columns, use the $ symbol and dot notation to denote each element inside the JSON property. Place the column path operator between the columns and their elements. Finally, execute the statement to return the output results from the activity table. You've now helped Lucky Shrub to create an optimal method of storing and accessing data from the activity table in their database. You should now be familiar with how to use JSON in MySQL to optimize the database. Great work! Congratulations, you've reached the end of the second module in this course. Let's take a moment to recap some of the key skills you've gained in this module's lessons. In the first lesson, you learned how to optimize database queries, and you now understand that database optimization is the process of maximizing the speed and efficiency of the database's performance when executing queries. You know that optimization focuses on 2 different kinds of statements: data retrieval or select statements, which return data from the database, and data change statements, used to alter data within the database. You learned that by optimizing a database, you can process data much more quickly and efficiently. During this lesson, you also learned how to implement different optimization techniques on select queries, including targeting only required columns in your select clause, avoiding the use of functions in predicates, and avoiding the use of a leading wildcard in predicates. You also learned to use inner join where possible, and make use of distinct and union clauses only when necessary. And you also explored the use of indexes to help maintain pointers that lead to sorted data. During your study of indexes, you learned that there are 2 types of indexes. The first is a primary index, also called a clustered index. The second is a secondary or non-clustered index. And you then reviewed the syntax for creating a secondary index. This involves using a create index statement, a custom index name, and the on keyword to target the required table and columns. In lesson 2, you explored further optimization techniques. Now that you've completed this lesson, you're able to make use of MySQL transaction statements to manage queries and roll the database back to its original state if any of the queries fail to execute as required. You can manage database transactions using statements like start transaction, begin or begin work, commit and rollback. You can start your transaction using start transaction. And you know that if you encounter an error with your queries, you can add the rollback statement to the end of your SQL statements to return to your start transaction point. As you worked through this lesson, you also learned how to optimize select queries using MySQL common table expressions. You can now use a CTE to compile complex queries into simple blocks of code. These blocks can then be used to rewrite the query by calling the CTE when required. This simplifies the query and makes it much easier to read and maintain. Start your code block using the with clause, then list the queries underneath. Finally, type your select statement followed by the query name. You can also execute multiple CTE at once using the union operator between statements. You then explored MySQL prepared statements. You can now make use of prepared statements to limit the number of times MySQL must compile and parse code. And you discovered how to interact with a MySQL database using the JSON data type. As you worked through these lessons, you also enhanced your understanding of the topics through reading items, tested your knowledge of optimization techniques in quiz environments, and demonstrated your ability to make use of MySQL optimization techniques in a lab environment. Having completed this module, you should now be able to make use of a wide range of database optimization techniques. You can deploy these techniques to make sure that your statements are compiled, parsed, and executed quickly and efficiently in MySQL. Great work! At this stage of the course, you should be familiar with the role that data analysis plays in databases, but it's also important to understand the close relationship between data analysis and data analytics. With data analytics, you can take the data collected during data analysis and convert it into useful information that can inform future business decisions. Over the next few minutes, you'll explore how this works and learn about different types of data analysis. Lucky Shrub have had a great holiday sales season. They've collected a lot of data around their sales. They now need to use this data to help plan for their next sales period. Lucky Shrub can use data analytics and related variables to make sense of this data and plan effectively for the future. So, Lucky Shrub's use of data provides a good base for understanding what the term data analytics means. Data analytics involves taking data analysis a step further by converting and processing the collected data into useful and meaningful information. This information is then used to inform and make predictions about future events. Data analytics also involves the use of special tools, which you'll explore briefly later in this lesson. So your next question is most likely, how do organizations make use of data analytics? Over at Lucky Shrub, they can make use of their data with data analytics tools to predict what products sell best and should be kept in stock, what kind of special offers attract the most customers, and how best to manage their online sales. However, before you can perform data analytics, you first need to analyze and generate insights into the data you've collected. This data is collected through data analysis and SQL queries. There are different types of data analysis that can be performed within a database. Let's take a few moments to explore these different types of data analysis and learn how they inform data analytics. Descriptive data analysis presents data in a descriptive format. In other words, it describes what happened. You can use the data extracted from a database to explain a particular event. For example, Lucky Shrub can analyze their sales over a specific period. They can then describe the period using this data by referring to top-selling products and profits that they made. Exploratory data analysis is the attempt to establish a relationship between different variables in a database. In other words, is there a relationship between variables A and B? Or can you establish a link between variables X and Y? Over at Lucky Shrub, they use exploratory data analysis to determine if there's any correlation between an increase in sales for a specific product and the season in which it's sold, like an increase in the sale of trees during the holiday season. Inferential data analysis focuses on a small sample of data to make inferences about a larger data population and draw general conclusions. Lucky Shrub often make use of inferential data analysis. Their data shows an increase in the sale of barbecue products over the summer months, so they can infer that this is the best period in which to sell these goods. Predictive data analysis uses existing or legacy data to identify paradigms and patterns. These patterns can then be used to make predictions about future performance. For example, Lucky Shrub's data show that the sale of gardening tools increases when these items are discounted. They can use this data to predict that further discounts will lead to more sales. And there's also causal data analysis, which explores the cause and effect of relationships between different variables. Did variable A cause B, or did variable X have any effect on Y? Lucky Shrub's data showed that many customers who bought gardening tools also bought outdoor lighting products. Causal data analysis is a great way for Lucky Shrub to try and identify the relationship between these purchases. Finally, know that database engineers often use the terms data analysis and data analytics interchangeably. Although separate concepts, they are closely linked. You can't have data analytics without data analysis. So be aware of this fact when working with data analytics. You should now understand the concept of data analytics and be able to recognize different types of data analysis. Well done. At this stage in the lesson, you should be familiar with the concepts of data analytics and data analysis and the differences between them. Over the next few minutes, you'll explore the relationship between MySQL and data analysis, along with the benefits and limitations of MySQL as a data analytics tool. Lucky Shrub make use of MySQL to host their data and carry out data analysis. Lucky Shrub's database processes a large volume of data every day, including online orders, client information, and data around the store's products. With MySQL, Lucky Shrub have an effective set of tools to host and work with this data. Over the next few minutes, you'll discover how Lucky Shrub can make use of MySQL to analyze this data. As you've progressed through these courses, you've learned how powerful MySQL is. And another advantage of MySQL is that it offers database engineers the tools required to perform data analysis on the data in their database. However, MySQL also has its limitations when compared to other more advanced data analytical tools. Let's take a few moments to explore these. MySQL databases are built using a relational database model. As you learned in a previous course, relational models structure data sets in related tables, and these related tables make it easy to access, retrieve, and analyze related information. With MySQL, Lucky Shrub can connect their database tables using foreign keys. This means that they can use one table to locate information in another. For example, the orders and products tables are both connected through the product ID key. This relationship helps Lucky Shrub identify the products that each client ordered. MySQL is also a free open source database management system, so there's no cost or intellectual property to consider when managing a database with MySQL. This is of great benefit to Lucky Shrub because it reduces the cost of doing business. And because of its capacity and accessibility, MySQL is a very widely used database management system. Large numbers of businesses, governments, and other organizations make use of MySQL to collect, store, and process data. This makes it easier for these organizations to communicate data and improve their data analytics. For example, Lucky Shrub suppliers also use MySQL to manage their data. So, Lucky Shrub can keep their suppliers up to date with information on their stock levels by sending them data from the products table in their database. However, despite all these advantages, MySQL also comes with limitations. MySQL's capacity to perform data analysis is much more limited than other more advanced data analytics tools. With these other tools, database engineers can perform much more complex data analysis backed by powerful artificial intelligence. MySQL also lacks data visualization features. Other database analytics tools offer database engineers visualization features like bar charts, graphs, and maps. These tools are a much more effective way of communicating information than just presenting data in the form of tables. With these visualization tools, Lucky Shrub could quickly spot trends in their data and identify any major issues. So, as you've just learned, there are a wide range of benefits to using MySQL as a database management system. It's free and open source, holds large amounts of data in a relational system, and is widely used across various organizations. However, its data analysis and visualization capabilities are limited when compared to other more advanced data analytical tools. Analyzing data in a MySQL database requires a good understanding of how to access data and extract relevant information using SQL queries. You should already be familiar with many of these, like subqueries, joins, and views. Over the next few minutes, you'll learn about the role that these SQL queries play in the data analysis process. Over at Lucky Shrub, they need to perform data analysis on the client orders within their database. However, the types of data analysis they need to perform are very different. They include simple data extraction tasks using basic SQL queries, and tasks that involve advanced subqueries, joining tables, and creating virtual ones. Once these tasks are completed and the required data is extracted, they can analyze it and prepare it for data analytics. Let's explore the relationship between SQL queries and the data analysis process to find out more about how they support Lucky Shrub's business. As you should already know, data analysis involves collecting and presenting the data in your database. The data can then be used to gather further insights to support the data analytics process in MySQL. Data can be collected from a database using a wide range of SQL queries. At this stage of the course, you should be familiar with many of these SQL queries. For example, you can extract or collect data using joins to join two tables together, subqueries to create a query within a query, and views to create virtual tables. You can also use functions to perform sophisticated operations and return different results, and filter required data using operators. So the basic process for performing data analysis in MySQL using SQL queries works as follows. You can extract the required data from your database using a wide range of one or more SQL queries. You can then use further SQL queries to present a description of the results of your data analysis. And you can then gain further insight from these initial results using data analytics. Let's explore an example of this process. Lucky Shrub need a list of all products that sold in quantities of 100 items or more. They can extract this data using a subquery that targets the tables that hold the data and filters the required results. Once they execute the subquery, MySQL returns the records that they need, a list of the top-selling products. Once Lucky Shrub identify their top-selling products, they can then use different types of SQL queries and data analytics tools to generate further insights and plan for the business's future. All these insights and potential strategies are made possible by the data collected through SQL queries. For example, now that they know what their best-selling products are, they can continue to buy more of them. And they can buy less of the products that don't sell as well. They could even offer discounts on certain items to try and increase sales. So, to recap this process, Lucky Shrub create a SQL subquery to target the data they require. They then extract this data from the database through data analysis. And this data can then be explored further using more sophisticated queries to generate business insights. Now that you're familiar with this process, it's time to put it into action. As you discovered a few moments ago, Lucky Shrub need to perform data analysis on their client orders. Let's see if you can help them out. The data that Lucky Shrub require is in the orders table in their database. They've extracted the data from the table, but they now need to target specific data that provides insight into the performance of the business. For example, Lucky Shrub need a list of all products that sold 10 items or more. You can extract this data with a select statement that targets the order table's product ID column. Then add a where clause that targets any product ID that has sales data. Next, add a subquery that selects product IDs from the orders table that sold in a quantity equal to or greater than 10. Execute the statement to extract the data. MySQL outputs a table that displays the required records. Joins are also a useful method of performing data analysis in MySQL. You can use different kinds of joins to explore the relationships that exist between data. Lucky Shrub need to analyze and extract data on their clients and the orders they placed over the last 10 days. However, the data exists in two separate tables. You can help them analyze the data in these tables using joins. Write a select statement to join the required columns from the orders and products tables using an inner join. Then use the between keyword to filter the client IDs and related orders from the required dates. Execute the statement to show the required data. Views are also helpful for analyzing data. They can be used to create virtual tables that focus on specific types of data. Lucky Shrub need to analyze their sales data and extract the top 5 best-selling products. You can use a select statement and a virtual table or view to help Lucky Shrub analyze their data for this information. Write a create view statement. Call the new virtual table top products. Then write a select statement that uses an inner join to combine the required columns from the products and orders tables. These tables hold all the sales data you need to help Lucky Shrub carry out their analysis. Finally, use an order by clause to order the extracted records in descending order. Then execute the statement. The statement creates a new virtual table called Top Products that shows the name, quantity, and cost of the top 5 best-selling products. You can use a select statement to extract all data in this virtual table to perform further data analysis. All these insights and potential strategies are made possible by the data collected through SQL queries. And what SQL queries you use all depends on what data you need to extract and analyze and what you want to achieve from this analysis. You should now be familiar with performing data analysis in MySQL using SQL queries. Great work! When analyzing data, there may be times you need to extract all records from 2 separate tables. You could use a join, but this would just return matching records. Sometimes you'll also need records that don't match. So the solution is to emulate a full outer join. This method extracts all records, even those that don't match. In this video, you'll learn how to emulate the full outer join or full join in MySQL to extract data from tables. Lucky Shrub need a list of all their new orders and the clients who placed them. They also need the data of clients who didn't place orders. This data is stored in 2 tables, clients and orders. MySQL supports inner, left and right joins, but these won't return the required data from both tables. So Lucky Shrub need to emulate a full join to extract this data. You can help Lucky Shrub to complete this task. But first, let's find out more about what a full join is and how it works. In SQL, a full outer join returns all records from a left and a right table when it identifies a match between the 2. This includes records that match and those that don't. However, MySQL doesn't support the full outer join, so you need to emulate it using a combination of the left join and the right join. You also need to use the union all operator to return duplicate records should they exist. Alternatively, you could use the union operator to retrieve unique records only. Let's take a few moments to explore the syntax for these methods. Here's how to emulate a full outer join using a union all operator. First, type a select command followed by the names of the columns that you require. Then use a from clause to target the first table, which is your left table. Next, use a left join clause to join the first table with the second table, the right table. Then use an on keyword and dot notation to equate the matching columns between the 2 tables. Now that you've scripted the left join, you need to create the right join. But you also need to combine these joins using a method that returns all duplicate records. It's at this point in your syntax that you can add the union all operator. Once you've added the operator, create the right join. As you should already know, the syntax is almost the same as the left join statement. The key difference is that you must use a right join clause. When executed, the union all statement returns all duplicate records, should any exist. But what if you only want unique records? To retrieve unique records only, you can use the union operator. The syntax is largely the same. You need to script a right join and a left join statement as before. But this time, place the union operator in between the 2 statements instead of union all. Then, when executed, the statement only returns unique records. For example, Lucky Shrub can use the union operator syntax to return unique records from the clients and orders tables. Let's see if you can help Lucky Shrub to emulate a full outer join using the union operator. As you learned earlier, Lucky Shrub need records of all new orders from the orders table and the records of the clients who placed these orders from the clients table. They also need the data of clients who didn't place orders. Start with a select statement. Then target the following required columns from the clients table using dot notation: client ID, full name, and contact number. Then target the following columns from the orders table: order ID, cost, and date. Then use the from clause to identify clients as the left table. Join it to the orders table with a left join clause. The next step is to use the on keyword to equate client ID as the matching column between both tables. Then add the union operator so that the syntax retrieves unique records only. Now it's time to script the right join statement. Again, the syntax is mostly the same as the left join statement. Just use a right join clause instead of a left join one. Finally, press Enter to execute the statement. The output shows all client IDs with their related order IDs. It also shows matching order IDs and client IDs, along with IDs that don't have a match. Lucky Shrub now have all the records that they require from their database, and you should be familiar with how to emulate a full outer join in MySQL using the union and union all operators. Good work. At this stage of the module, you should now be familiar with the data analysis process and how the results can inform data analytics. Now let's look at an example of how to perform data analysis in MySQL by querying multiple tables using joins. Lucky Shrub need to identify all clients who bought 10 items or more from a specific product line so that they can send them a special offer to make more purchases. The clients must have made their purchases after the 5th of September 2020, and there must be 50 units or more of the product currently available in stock so that all special offers can be redeemed. There are 3 tables in the database that contain the required data: the orders table with information on each order, the clients table which contains key information about each client, and the products table which holds the data on all products in the store. You can help Lucky Shrub to query these tables by using an inner join to target the following data: the client ID and contact number columns from the clients table, the order ID, quantity and date columns from the orders table, and the number of items column from the products table. Let's get started. Begin with a select statement, then use dot notation to identify the required columns from each table. Next, use an as keyword to create an alias for the product table's number of items column. Rename it as items in stock. Then target the clients table with a from keyword and use the inner join clause to join it to the orders and products tables within a pair of parentheses. The first join is created between the clients and orders table using the client ID column, which exists in both tables. The second join is created between the orders and products tables using their respective product ID columns. Next, add a where clause and parentheses. Within the parentheses, state the following: customers must have purchased 10 or more units of the item. All purchases must have been made after the 5th of September 2020, and there must be at least 50 units of the item currently in stock. Finally, click Enter to execute the query. MySQL extracts the required data from the tables and displays it on screen. You've now performed data analysis on 3 tables within the Lucky Shrub database, and through data analytics, you can use this data to identify clients that you can send special offers to. Great work! Congratulations! You've reached the end of the 3rd module in this course. Let's take a moment to recap on some of the key skills you've gained in this module's lessons. In the first lesson, you learned how to evaluate MySQL for data analysis. You are now able to explain that data analytics involves taking data analysis a step further by converting and processing the collected data into useful and meaningful information. This information is then used to inform and make predictions about future events. You then learned about the main types of data analysis. These are descriptive data analysis, which presents data in a descriptive format; exploratory data analysis, used to establish a relationship between different variables; inferential data analysis, used to make inferences about a larger data population and draw general conclusions; predictive data analysis, which identify paradigms and patterns; and there's also causal data analysis, which explores the cause and effect of relationships between different variables. You also learned about the benefits of using MySQL as a database management system, particularly when it comes to supporting decision makers in an organization. The primary benefits of MySQL are that it's free and open source. It holds large amounts of data in a relational system. It's widely used across various organizations, and it also offers database engineers the tools required to perform data analysis on the data in their database. And you also know that there are limitations around MySQL's ability to perform data analysis. For example, it's less powerful than other tools and lacks data visualization tools. In Lesson 2, you learned how to perform data analysis in MySQL. Now that you've completed this lesson, you should be able to perform basic data analysis using SQL queries. In this process, you extract the required data from your database using a wide range of 1 or more SQL queries. These SQL queries are used to present a description of the results of your data analysis and to gain further insight from these initial results using data analytics. You then explore the different kinds of SQL queries that can be used to perform data analysis. You can emulate a full outer join to return all records from a left and a right table when it identifies a match between the two. This includes records that match and those that don't. You also learned that you could use the union all operator to return duplicate records, or the union operator to retrieve unique records only. However, MySQL doesn't support the full outer join, so you must emulate it using a left and right join. You can also use functions to perform sophisticated operations and return different results, and filter required data using operators. You can make use of subqueries to create a query within a query and deploy views to create virtual tables. And as you work through these lessons, you also enhanced your understanding of the topics through reading items, tested your knowledge of optimization techniques in quiz environments, and demonstrated your ability to make use of data analyzation techniques in a lab environment. Having completed this module, you should now be able to evaluate MySQL for data analysis and perform data analysis in MySQL. Great work! I look forward to guiding you through the next module in this course. In this course, you learned about advanced MySQL topics. Let's take a few moments to recap the key lessons you encountered during this course. In the opening lesson, you received an introduction to advanced MySQL topics. During this introduction, you learned about advanced database engineering. You discovered how Meta makes use of advanced database engineering techniques, and you learned how to make the most of the content in this course to ensure that you succeed in your goals. You then moved on to the next lesson, in which you learned about functions and stored procedures. In this lesson, you learned how to create and work with functions and both basic and complex stored procedures in MySQL so that you can reuse or invoke code blocks to perform specific operations. You then learned how to make use of variables and parameters to create more complex stored functions and procedures in MySQL. And you learned how to develop user-defined functions for when MySQL's built-in functions don't meet the needs of your project. You then moved on to the final lesson in this module, in which you learned how to use MySQL triggers and events and automate database tasks. In this lesson, you discovered that a MySQL trigger is a set of actions available in the form of a stored program. These set of actions are invoked automatically when certain events occur. You explored different types of MySQL triggers like insert, update, and delete, and you learned how each type can be used to control the behavior of your triggers. And you also developed an understanding of how you can make use of scheduled events to ensure that your database tasks and events are completed at specific times. You also reviewed other aspects of the syntax used to create a MySQL trigger. You're now familiar with the create trigger command and defining the trigger name and type, and specifying the logic of a trigger by enclosing multiple statements with a begin-end block. You then moved on to the second module, in which you learned about the core rules and guidelines for database optimization. In the first lesson of this module, you explored how to optimize database queries, and you developed an understanding of the concept of database optimization and the advantages it brings to a MySQL database. You also reviewed techniques for optimizing database select statements so that they're executed quickly and efficiently. For example, targeting required columns or avoiding the use of complex functions. And you also learned how to work with indexes in MySQL to speed up the performance of data retrieval queries. The second and final lesson in this module presented an overview of further optimization techniques. You began by learning how to use MySQL transaction statements to manage database transactions. You then discovered how you can use common table expressions to manage complex SQL queries by compiling them into single blocks of code. You learned how to make use of prepared statements to limit the number of times MySQL must compile and parse code. And you discovered how to interact with a MySQL database using the JSON data type. In the third module, you explored the relationship between MySQL and data analytics. The first lesson in this module focused on evaluating MySQL for data analysis. First, you developed an understanding of the relationship between database analytics and MySQL. And then you discovered how to make use of data collected during data analysis by converting it into useful information that can inform future decisions. You also explored the different types of data analysis that can be performed within a database. You then moved on to learn about the relationship between MySQL and data analysis, including the benefits and limitations of MySQL as a data analytics tool. In the second lesson of this module, you learned how to perform data analysis in MySQL using SQL queries like joins, subqueries, and views. You then explored how to emulate a full outer join in MySQL to extract all records from two tables, including those that don't match. And finally, you learned how to extract data from multiple tables using the join method. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your MySQL journey, and you should now understand advanced topics in MySQL. You are able to demonstrate some of this learning along with your practical MySQL skill set in the lab project. You should now be able to deploy functions and triggers in a MySQL environment, optimize a database, and perform data analysis using SQL queries. The graded assessment then further tested your knowledge of these skills. However, there's still more for you to learn. So if you found this course helpful and want to discover more, then why not register for the next one? You'll continue to develop your skill set during each of the Database Engineer courses. In the final lab, you'll apply everything you've learned to create your own fully functional database system. Whether you're just starting out as a technical professional, a student, or a business user, the course end projects prove your knowledge of the value and capabilities of database systems. The lab consolidates your abilities with the practical application of your skills. But the lab also has another important benefit. It means that you'll have a fully operational database that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses in this specialization, you'll receive a certificate in database engineering. The certificate can also be used as a progression to other role-based certificates. Depending on your goals, you may choose to go deep with advanced role-based certificates or take other fundamental courses once you earn this certificate. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.